Welcome students to Inverses of Square Root Functions. And this is on page 5 of your notes for Unit 6 and 7. So remember to find the inverse of a function. You swapped the x and y values. So let's first do inverses on graphs, inverses on tables, and then we're going to do finding an inverse algebraically. So I've got this equation, f of x equals the square root of x plus 2 minus 3, and I've already graphed it for you here. And then on the side, I have a few points from that graph. So I have negative 2, negative 3, negative 1, negative 2, and then 2, negative 1, 7, 0, and 14, 1. So I've got those points. So if I wanted to see what the inverse looked like, I need to swap the x and y values. So this is my function. This is my original function. And this is my inverse. To get the inverse, so this negative 1 right here means inverse. This is the inverse of the function f. And to get the points for the inverse, I'm just going to take the x and y and swap them. So instead of having negative 2 and negative 3, I'm going to have negative 3, negative 2. So I'm going to go graph that, negative 3 and negative 2. And then instead of negative 1, negative 2, I'm going to have negative 2, negative 1. So negative 2, negative 1. And then instead of 2, negative 1, I'm going to have negative 1, 2, and so on. So negative 1, 2. And then 0, 7, and 1, 14. 0, 7, and 1, 14. So there's the points, the matching points that are on the inverse there. So let me sketch that in. It's not the nicest picture, but you get the idea. Much better. All right, so there's my original function and there's my inverse. And remember, when you graph a function with its inverse, you've got this spiffy diagonal line going on here. They always reflect right over the line y equals x, just like that. So you know they're inverses when they reflect each other, like this. And then when you check the tables, you know they're inverses when the x's and y's have just swapped places. So that's all it is, inverses by graph and inverses by table. All right, so algebraically, we're just basically doing reverse Pemdas. So, with a twist, I guess. So I'm going to start with my example. I want to find the inverse of this function here. It's the same one as above. And my first step, go ahead and change f of x to y because that's what it is. That's where y goes. And then I want to swap the x and y because that's what inverse means. So I'm going to swap the x and y. So I'm going to have x equals instead of y equals. And then here when I get to x, I'm going to put a y instead. And then basically I just want to do reverse PEMDAS until that y is by itself again. So first I want to, let me go and write it here, even though I've got it in the instructions. So first I want to add or subtract anything that's outside that square root. And I do have a 3 I can get rid of. Let's do that. Now the temptation here is to take x plus 3 and write 3x, but remember that means multiplications. Don't put 3x here. Put x plus 3. So x plus 3 is just x plus 3. Then equals y plus 2. So that's done. Now, do you see any multiplication or division I could do over here to try to get this y by itself? Well, no, there's really not anything there. So the only things that are in there are inside the square root. So I can skip that step. Now I'm on the exponent step, which means I need to use an exponent to cancel out the square root itself. So to do that, I'm going to use a 2 for my exponent. And I'm actually going to rewrite it down here a little bit so I have more space. There, so I started with x plus 3 equals square root of y plus 2, and I just squared both sides. Now be careful when you square this side. Notice, what did I do? I put parentheses around the whole thing because you're squaring the entire thing. And then you can leave it in that form. No need to do box method multiplication or anything like that. So those cancel out. And then I have x plus 3 squared equals y plus 2. And then subtract 2 from both sides. And I end up with y equals x plus 3 squared, and then just minus 2. So there's my inverse. Now, so you can see this equation here is a full parabola. It's a full quadratic, but our inverse is just the half of one. So what you have to do is restrict your domain. So notice our x's start at -3 and then get larger. So you're just going to put x is greater than or equal to -3. And that is your inverse function.